I'm Pranam Mittal and I'm here with.
Rowan, and today we're diving deep into a subject that sits right at the intersection of maths, computer science, and society: algorithmic bias.
It's one of those things that sounds abstract but has real world consequences, from hiring decisions and facial recognition to criminal sentencing and medical diagnosis. AI is everywhere and it's not always neutral.
Exactly. Algorithmic bias refers to systematic errors in AI systems that cause unfair or discriminatory outcomes. And what's wild is these biases often stem from the way the AI learns.
So, the big question we're asking today is, can we challenge algorithm bias? Is it baked into maths or are we just not trying hard enough to fix it? Or wait, do we even need to fix it? Let's start with how AI actually learns. So, Rowan, most AI systems use supervised learning, right? Say we were teaching a model to identify cats in images. We'd feed it datasets full of labeled pictures, cat or not cat.
Yeah, but the AI doesn't really understand what a cat is. It just sees patterns. Maybe pointed ears, whiskers, or a tail. It makes a guess, then compares that to the real label and calculates how long it was.
The error is plugged into a loss function, a formula that says, here's how bad you did. The model then uses gradient descent to update its weights and improve next time.
Think of tuning a radio dial to reduce static. The model keeps tweaking itself until the signal becomes clear, which is minimum error. But here's the key: whatever patterns are in the training data, even biased ones, the AI learns them.
That's interesting.
So where does the bias come in then? It's from the data. AI trains on the world as it is at the moment, but the world is full of historical inequalities, so that creates a huge problem.
A perfect example would be Amazon's AI hiring tool. It was trained on 10 years of resumes, mostly from men. And the result? It penalized resumes with terms like women's colleges or women's clubs.
Yet it learned that the tech industry was male dominated, so it prioritized male resumes. And that's not just a glitch, it's a reflection of societal bias creeping into machine learning.
And then there's facial recognition. Early datasets were filled with lighter skinned faces, which led to wildly uneven performance. Mind me for my mispronunciation, but two researchers, Joy Bulamwini and Timnit Gebru, found that some systems had error rates as low as 0.8% for white men and up to 34.7% for darker skinned women.
Yeah, just take a moment and let that really sink in. These aren't just coding bugs, they're structural issues. If the training data is biased, the outcome will also be biased. If you put garbage in AI, it just produces injustice out.
And it gets worse when you scale it up. The Compass risk assessment tool used in US criminal courts predicted whether someone would reoffend.
Because historical data showed higher arrest rates for black people, the model learned that black defendants were a higher risk, even when that wasn't true.
ProPublica, a company, found that Compass, the risk assessment tool, incorrectly labeled black defendants as high risk and nearly doubled the rate of white defendants, even when both had clean records.
So what happens then? A biased tool influences real-world sentencing, and the system ends up reinforcing the very inequalities that it should be fixing. Even if the bias is partly inevitable, we can't just accept it as the status quo. The human consequences are just too severe.
Take Robert Williams, a black man from Detroit. He was wrongfully arrested in 2020 after facial recognition software falsely identified him as a suspect.
And that's important. Robert is part of a racial minority that already faces over-policing and surveillance. Because of flawed tech, he was jailed overnight and traumatized. That's all due to algorithmic misidentification.
That seems really unfair. And in lending or hiring, biased AI can mean being denied a loan or job opportunity for no reason except that your profile matches historical patterns of disadvantage.
That violates principles like the Equal Credit Opportunity Act, which bans discrimination in credit decisions. Again, these are real harms, they affect real people, so that's why it's such a big problem and why we have to act. So now let's move on to talk about IBM's Diverse in Faces, or DIF project. In 2019, IBM released a dataset of over 1 million facial images, but here's the key. Each image was meticulously annotated for age, skin tones, that was based on the Fitzpatrick scale, gender, and pose.
Why? That's because existing facial recognition datasets were overwhelmingly biased towards lighter skin tones and younger faces, resulting in poor performance for others.
IBM's goal was to diversify the representation of human faces used to train AI, and it worked. They achieved a 28% reduction in error rates for gender classification of darker-skinned individuals.
So yes, direct, data-level interventions can fight bias.
And ethically, it's not just about data. Think about Project Maven. Thousands of Google employees protested when they found out that AI was being used for drone footage analysis, potentially enabling lethal autonomous systems.
That internal protest led to Google pulling out of the project. It shows we can and must challenge unethical uses of AI, because who knows what AI in drones, especially in cases of war, could have led to. I understand your argument about us needing to challenge AI, but is it really possible? Can we really challenge algorithm bias? So now let's talk about the theoretical war that goes against your argument. Kleinberg's impossibility theorem.
Yeah, go on, lay it out.
In 2016, Kleinberg, mind my pronunciation, Mullainathan and Raghavan showed that when two groups have different base rates, like different loan repayment rates, you cannot create an algorithm that satisfies all three fairness criteria. Now, the three fairness criteria are, firstly, calibration. Confidence scores should be equally reliable across each group. Secondly, we have equal false positive. No group should be wrongly flagged more often. Equal false negatives. No group should be wrongly excluded more often. So, equal false positive, equal false negatives, and first one was calibration.
Yeah, the math proves it. You can't have all three unless the world was already fair to begin with, which it, of course, isn't.
Exactly. We don't start with all three fairness criteria being satisfied, so we cannot end with them being satisfied either. You will always miss out on at least one of them. And as long as you miss out on one of them, you will have algorithm bias, either in being flagged as a false positive or false negative, or not being calibrated. So now, the Compass case shows this in action. ProPublica had criticized the unequal false positives. The company defended that the model was well calibrated. Both were right, but they were using incompatible fairness definitions. And if you use Kleinberg's impossibility theorem, there has to be a condition that's not satisfied, and in this case, it was unequal false positives.
So, even if we can't entirely get rid of all bias, we can contain it. Let's move on to talking about some strategies for mitigation.
That's true. I mean, maybe it is impossible to completely get rid of algorithm bias, but we can limit it. So firstly, we have data rebalancing. This is about adjusting the dataset to be more representative. For example, if black women are underrepresented in facial recognition data, you can oversample or augment their examples so the model sees them more during training.
Or even synthetic data generation using techniques like GANs to create realistic new examples for underrepresented groups.
Secondly, we have label correction and fair target design. Labels like who reoffended or who defaulted may be inherently biased if the data reflects historical injustice, so correcting mislabeled outcomes is crucial. So now the data has correct data to train on.
Yeah, this means rethinking how we define success or risk. Maybe we just need to rebuild our targets, not just our features.
Thirdly, we have removing or encrypting protected attributes. Sometimes removing race or gender helps prevent models from learning proxies for them.
But in fairness-aware modeling, retaining those attributes helps to explicitly correct for disparities. Context matters. Don't blindly just get rid of stuff. You've got to understand why and how. You've also got human-in-the-loop oversight. Algorithms are tools, not just judges. Critical decisions, such as hiring or prison sentencing, still have to involve humans who can weigh broader context into the decision.
And those humans must be diverse. A monoculture engineering team may never spot issues that are obvious to someone else's lived experiences.
You've also got red teaming and bias audits. So you can have separate teams intentionally trying to break the system and expose where it fails by simulating edge cases or adversarial scenarios, a bit like penetration testers in computing.
Bias audits, both internal and external, can catch flaws before deployment. It's like ethical pen testing.
You've also got policy and culture. If you foster a culture that questions the moral use of tech and empower engineers to push back, such as in Project Maven, the culture can make a difference.
And then there's regulation. GDPR and the EU AI Act require transparency, documentation, and accountability.
Yeah, there's also the Apple Card controversy, where women consistently got lower credit limits than men, which showed regulators are watching.
We need external enforcement, not just corporate promises. So let's wrap this up. Bias in AI is partly inevitable, it's how the systems learn, and mathematically perfect fairness is impossible, as we explored by how the data is trained and by Kleinberg's impossible theorem.
But inevitability doesn't mean acceptability. It means we need to fight harder, smarter, and more ethically.
Case studies like Amazon, IBM, Compass show us what happens when we do nothing and what happens when we do something. It's important we take action. For example, IBM's diversity in faces project or Project Maven.
Our job as humans is to choose the fairest trade-offs to build transparency, and also to speak up when systems do cause harm. Because the future of AI is not just about what it can do, it's about what we allow it to do.
And that is the perfect spot to finish it. I hope you all enjoyed this podcast. If you have any questions, please leave a comment and we will answer your question as soon as possible. So make sure to like, share, subscribe, comment, like, and follow, and subscribe, and all that across all our platforms. See you in the next episode.
Goodbye.
Goodbye.